All right, in our previous lesson, we talked about graphing the sine and cosine functions with changes to the amplitude and to the frequency. In this lesson, we want to now introduce translations to the mix. In other words, when we horizontally or vertically shift a function up or down or to the left and to the right. And I went ahead and I just filled out already the things that we're going to need in order to graph our functions, now that we're really just putting all of our transformations together. So take a moment, pause the video if you haven't already done so, and just jot these down, but I'll start going through them. We already know about our amplitude and frequency along with our period. When it comes to a horizontal translation, remember it just doesn't directly mean we're just adding or subtracting whatever our C value is. In other circles, we call this a phase shift, or I'm going to continue to call it a horizontal translation. But what it effectively just means is that we want to go ahead and set our argument equal to 0. This is no different than what we've been doing so far with all of our horizontal translations to our functions. We're going to set our argument equal to 0, and we're going to see what happens to our x. Remember, we're trying to undo what's actually happening there. So if we set bx minus c equal to 0, we want to do the opposite of what is algebraically written within the argument. Our vertical translation is a lot more straightforward. We're just going to add or subtract whatever our d value is. But I do want to highlight here what that means for us is that we are going to then vertically shift our entire function either up or down, which results in what we call a midline. And I will try to demonstrate this in our next example. Okay, so our steps for graphing are written out here below. And just going through step by step, we want to make sure that we find our amplitude, our frequency, our period, find our period divided by 4, which again is going to be the horizontal distance between each one of our critical points. Make sure you identify any transformations, because all this information is going to help you figure out the scales for your axes. And I really want to emphasize this. This might be the most important part of your graph. Because honestly, once your scale is set up, then the rest of it just kind of falls into place. You're literally just filling in points and connecting the dots. Once we have our scales set up, we're going to then want to make sure we check for any vertical translations, which is going to change our midline, and then use those transformations to start plotting the points. So let's actually take a look at an example right now, because I think it'll help us understand this best. So consider the function y equals 2 sine pi x. And just to be very clear, our argument here is pi x, okay? If I wanted to include that plus 3 as part of the argument, then I would move the parentheses to be outside of that. But we have the function y equals 2 sine pi x plus 3. And we're going to graph 2 full periods or 2 full cycles of this. Well, let's go ahead and jot down what we know. Well, we know our amplitude is going to be 2. Our frequency is going to be pi. And then to calculate our period, we're going to take our 2 pi and divide it by our frequency, which means our period is 2. And that's going to be really important. Notice that there's no pi in our answer. Our length of one full cycle before it starts to repeat itself is going to be 2. No pi notation in there. Now, to find our c over b, again, we can just find our c value, which is 0 over b, which is pi, which is equal to 0. Alternatively, we can take our argument here, pi x, set it equal to 0, and just ask ourselves, well, what are we doing? What do we need to undo to get to just x? So we have 0 over pi, which is just 0. It's the same thing as we have written over there to left. Our d value is going to be 3. Make sure we note that that is a vertical shift up 3. And our period divided by 4, which helps us figure out our distance between our key points, is just going to be our period that we found in our previous step. So 2 divided by 4 is equal to 1/2. Okay? And let's talk about the domain and range after we've graphed it so that we can visually see. So when we went ahead and I just labeled our y-axis 1 through 5, and again, I try to do it to the left or to the right so we don't write it actually on the axis and end up making things a little bit messy. And I apologize, my y-axis here looks like it's kind of shifted over a little bit. So don't worry too much about that, but let me see if I can just kind of fill this in. There we go, that looks okay. Or good enough at least. All right, So now let's go ahead and label our axes. And again, this is the most important part. We've figured out our y. Now for our x-axis, we want to think about our period. Our period is 2, and the length or distance between each one of our key points is 1/2. So I'm going to skip every 2 kind of little dashes here and make this 1/2. Then the next one would be 1. And I'm leveraging that bit of information over here. And then this would be 3/2. And this would go to 2. And remember what I said in class. Anytime we have a critical point, we need to make sure that our x-axis is labeled. So going the other way, -1/2, -1, -3/2, and -2. Okay? So this is going to ensure that I have enough space to graph 2 full periods. And you'll notice that in the directions, I didn't say anything about you need to have one period on the negative x-axis and another period in the positive x-axis. I'm just going both ways just so we can see them on both sides of the y-axis. But if you wanted to graph this from 0 to 4, there's nothing stopping you from doing that. Okay. So with that said, let's think to ourselves and ask ourselves, where would my function be starting? Well, it's a sine curve, so it's going to start at its mid, right? Or normally where there would be resting on the intercept. But because of our d value here, and let me actually just do this in a different color. Because our d value here, we have a vertical shift up 3. So normally we would be at 0, 0, but with this vertical shift up 3, and let me just actually do this using this dash line here, and make this a little bit larger. Our midline is going to be right here at 3. Okay? So that's going to change where our starting point is going to be. So instead of starting at 0, 0, I'm actually now starting at 0, 3. Then I want to move up to my quote-unquote high point. Well, this is now where I look at my amplitude. My amplitude is 2, meaning the distance between the highest point on our graph and the midline is going to be 2. So I go up to 5. Then I go back down to the midline. Then I'm going to go down to its minimum point, which also should show that I have an amplitude change of 2. Right? Remember, when I'm talking about the amplitude, I'm referring to this distance here being 2. Okay, same deal. This distance here being 2. Okay? All right, I'm just going to erase that just so it doesn't muddy up our graph too much. And this should complete one full cycle. So mid, high, mid, low, mid. It's kind of the way I've said to graph it. So I'm going to go ahead and move that down and just start connecting the dots and try to be as accurate as you can with this. No hairy graphs. Try not to let it too much look like a bunch of V's, if you will. Okay, so that is one full cycle. Let's now go the other way. If we go the other way, I can start here at -2, which I know should be the beginning of a new cycle or new period. This goes up here, mid, and I believe I should go down a little bit more, low, and then mid. Okay, so again, connect the dots. And that should do it. So that is 2 full periods of the graph that we have there. Okay. Now that we're looking at that, let's look at our domain. Now, the domain of any sine or cosine function is always going to be all real numbers, okay? Because remember, sine and cosine, like any trig function, are cyclical. There are no domain restrictions for sine or cosine, so we can say that our domain is always all real numbers. There's nothing that's really going to change that. Now, for our range, this is where we look at our vertical shift and our amplitude. We notice that the lowest our point can be is +1, and the highest that our point can be would be +5. And then ask yourself, is this inclusive or non-inclusive? It does include those points, so we should be using brackets for interval notation. Okay? All right, let's go ahead and try another one. Well, we'll do one more together, and then I'll leave one for you to try completely on your own, and you can always check Google Classroom and see my completed notes for this just to make sure that you're correct here. So right underneath this, I'm going to just kind of help myself here and just remind myself, y is equal to a cosine bx plus c. And normally there would be a D there, but since I don't see anything, that probably tells me that my D is just going to be 0. So I'll just fill that out right now. Okay, so let's go through this and fill out our table and make sure we fill out everything that we know. Our amplitude is going to be 4. Our frequency is 3. Our period is always 2 pi divided by our frequency. So this is just going to be 2 pi over 3. Our C over B, we can just go ahead and say that is pi over 3. But something that I want to point out, because I think I can illustrate a little bit better here. By setting my argument, 3x plus pi equal to 0, we can see what's exactly happening to our argument. This is negative pi. So x should be equal to negative pi over 3. And that's where I intentionally left off that negative here, because I want to remind you that it should be bx minus ci. So I miswrote that there. I apologize. But I meant to really try to emphasize that this should be negative pi over 3. Okay? So again, our x value is at negative pi over 3. We're undoing what was there before. Okay? Now our period over 4 is going to be 2 pi over 3. There's our period. Since we're dividing it by 4, same thing as multiplying by 1/4, that's just going to be pi over 6. So that is the horizontal distance between each one of our key points. Our domain, might as well just write negative infinity to positive infinity. We know that's not going to change. And our range, let's see if we can ask ourselves, do we know what the range is now before we start setting up our graph? Well, I don't have any vertical shift, but I do know that my amplitude is now changed to 4. So my previous range, make sure we understand what our previous range for the parent function of cosine x would just normally be negative 1 over 1, or negative 1 to 1, excuse me. But because of our amplitude change, that negative 1 is going to go all the way down to negative 4, and that 1 goes all the way up to positive 4. All right? So the reason we do all the heavy lifting right now is because this helps us set up our graph and our axes. And once we have that, then we can do the rest pretty easily. All right, so let's do the vertical axis first. So the y-axis, we just said our range is going to go from negative 4 to 4. So we want to label this all the way up to positive 4. And then for our x-axis, we want to graph 2 full periods. And our period length is going to be 2 pi over 3, okay? Now, there's a number of different places where you could start this. Keep in mind that we have a horizontal shift to the left. I should probably write this here a little bit more clearly. This is saying here we have a horizontal shift to the left, pi over 3. And that's important because that quote-unquote gives us our starting point. Okay, I'm using that term kind of using air quotes, pi over 3 to the left as being our starting point. Because, again, the cosine graph is continuous in both directions. There is no one starting point. It's just a starting point that we use for ourselves when we start graphing. So I know that I want to start at negative pi over 3. A full period is going to be 2 pi over 3. So one full cycle would go from negative pi over 3 to positive pi over 3. So if I want to make sure I have enough space to graph all this, I'm going to kind of just say this is negative pi over 3. And then I'm going to add pi over 6 units in each direction. So negative pi over 6, this would be 0, pi over 6, and this would be positive pi over 3. Okay? I want to graph just one full period for now, just so you can see how we would start, and then you can continue filling out the axis in either direction. So negative pi over 3, again, is my quote-unquote starting point. Since this is a cosine graph, I'm going to start at my higher point. So at negative pi over 3, I'm going to start out at 4. Okay? I don't have any type of vertical shift to worry about, so I know that my mid is going to fall on the x-axis. It's going to be an intercept. So there's a mid. Then at 0, I'm going to go down to negative 4. Okay, and my y-axis is a little off, but it's okay. Then I go back up to the mid, and then to its high, or its maximum again. So the points should look like they're forming a V. We know better. We know the graph is actually going to look something like this. Okay, that should be pretty good. All right, so that is one full period. I didn't give you any requirements about which way we need to be going. So if you want to continue on in the positive direction, right? So I'm actually just going to change colors here just so we can see that. If we want to continue on in the positive direction, we would go pi over 2. This would be 2 pi over 3. There's my 3. 5 pi over 6. And then that should be just pi. So if I want to continue on in the positive direction, so high, mid, low, mid, and then high. So your graph here would look like this. And if I wanted to go in the negative direction, those of you who wanted to go that way, then we would just want to continue those points, but in the negative direction. So negative pi over 2, negative 2 pi over 3, negative 5 pi over 6, and then negative pi. So this should be high, mid, low, mid, and then high again. Max, intercept, minimum, intercept, and then maximum. And there's all that there is to that. So I went ahead and I graphed 3 full periods here. It only asked for 2, but I did 3 just so I can show you either way which way you could have gone. Okay, so I hope that helped. Go ahead and try that next example on your own. It should really give you a good sense of how well you're getting how to graph all of these transformations. And as you've probably figured out, the biggest thing is really just making sure that you get your axes labeled correctly. From there, it's just plotting points and then connecting them. So again, check my solutions to make sure you do the next one correctly.